I have to tell you, this is incredibly weird formula. There are two kinds of orbits. There are these guys that run, and then there are orbits that go someplace and come back. So there are orbits which are periodic orbits in a full state space. So they cannot contribute to diffusion because they don't move after one period. So the standing guys don't contribute to diffusion, but they contribute to the computation of mean time, because this is over all periodic orbits in fundamental cell. So what it tells you is that when you look at phase space of this disk, there is part of it that leaves and part of it that stays. So you cannot just throw standing trajectories because they show up here. They don't show up here because this is 0, but they show up there. So they construct the measure. For standing trajectory, the numerator is 0. So they don't contribute to the diffusion, but they contribute to the definition of the measure. Now, this is totally weird because every contribution here that's non-zero is actually running ballistically in time. So every contribution here is going, its distance grows as the time times the mean velocity per one, closing in here I can compute mean velocities. So I'm adding a bunch of numbers, all of them that are proportional to time squared because I'm squaring them. And they will actually produce a finite number. So I'm computing this in terms of, shooting my gun in all directions ballistically. It shadows ergodic orbits, which I know don't go ballistically because they go as square root of the distance. Time goes, the distance goes as, square root of time. But I'm computing by adding everybody going proportional to time. So, it's not obvious to me. It works. It's one of these wonderful things about theoretical physics. You put lots of things that behave differently. Now, how did this happen? These guys who are growing are being exponentially suppressed by the fact that their measure is very small. According to the length of the period, the measure is dropping down exponentially, the weight of a given cycle. So even though they're all going like t squared, they actually don't contribute very much because they contribute exponentially little. And this is all designed in such a way that we have that S of 0 is 0, meaning that's probability conservation. We cannot leave. So we have some constraint on sum of all lambdas that they all add up to 1. When you add them all up, and that's test of qualitative calculation. And now we are weighting these little pieces, and we get a finite answer. And I claim we should write the same formula for turbulent fluid dynamics, which has continuous in it, but I have not written it down, so it's open.